Hi to all. Welcome to another session on hyperbolic functions. So this is my class number 2 on hyperbolic functions. Already I did this class but unable to share with you too because of some technical issues. So in this class once again I would like to bring some of the hyperbolic functions and their domains and their ranges, and also a little bit about graphing and also inverse of the hyperbolic functions. So first I would like to complete sine hyperbolic function. So as you know that sine hyperbolic function is equals to a to the power x minus e to the power minus x divided with 2. So difference of these two divided with 2. So as you know, e power x expansion 1 plus x plus. So first of all I am replacing x by, I am checking for the symmetry. Sine h of negative x is equals to a to the power negative x minus of minus, that means positive x only, so whole divided with 2. So if I take minus common, I am getting minus sine hyperbolic function. Minus I am getting outside. So sine h of minus x will be minus sine x. So the function is said to be odd function. One thing is clear here, the function is odd. If the function is odd means it is symmetric about. It is symmetrical with respect to origin. The graph is symmetry about origin. So first definition, sine hyperbolic function, and checking of whether it is even function or odd function. Clearly I got the function is said to be odd function. So odd function is symmetry about origin. And to find the domain I am writing shortly d suffix f. So domain of any function is nothing but set of all inputs. That means what are the possible values of x that I can give to the function. So here the function is defined. If I take e power x minus e power minus x whole divided with 2. Check any dangerous values are there. Here nothing is danger here. The function is defined for every value of x. I can take x is equal to 0. So I am checking with some fundamental points. X is equal to 0. That means e power 0 minus e power 0 by 2. So this will give 0. When x is equal to 0, I am getting 0 itself. I am checking with endpoints. If x is tending to infinity, x is tending to infinity, that means e power infinity minus e to the power infinity minus by 2, that means it will do infinity. And similarly x is tending to negative infinity, y also tending to negative infinity. So these will help us to determine the range and also as well as the graph of the function. So first of all, domain of the function. So domain is, I can give any x values here. The function is defined for every input of x here, because something will give undefined, something unable to keep means it won't come under the domain. So domain will be set of all real numbers. So to get the range, you can observe this here. I am getting 0, I am getting negative infinity, I am getting positive infinity. So therefore, range of the function is also set of real numbers. So sine hyperbolic function, I got everything. The function is odd, domain, range, and also some fundamental values of the function. So by using this, I can picturize graphically, and taking so horizontal axis and vertical axis, axis of y. So origin, meeting point, and 1, 2, 3 inputs. So up to infinity, positive side, negative 1, negative 2, negative 3, up to negative infinity. Negative side, inputs here. Outputs 1, 2, 3, 4, up to infinity. And negative 1, negative 2, negative 3, up to infinity here. So 0 means 0. When x is equal to 0, y also 0 here. And I am moving along positive side here. From here to this side, moving positive side. Now y also moving to infinity. So stretching and extending to up to infinity. And when you come to negative side, if I go inputs along this side, negative side, so x is moving from here to this side. The y is also turning to negative infinity, negative infinity. So this is a sine hyperbolic function. Sine hyperbolic function. So we got the complete information about hyperbolic function. Domain, set of real numbers, and also range, also set of real numbers. After completion of this one, I would like to share inverse hyperbolic function also, because that is examiner area. They're giving one or two questions, one question based on inverse hyperbolic function most of the time. So to find the inverse of any function, just you are interchanging x and y. You are converting x with respect to y. So here hyperbolic y is equal e to the power x minus e to the power minus x by 2. So by using algebraic way, by using fundamental conversions, I need to solve for x here. First I am taking 2y. So 2y is equals to, so this is nothing but sine hx here, sine hx. So 2y is equal to e power x minus e power minus x here. Now by writing this one, this is nothing but e to the power x minus 1 by e to the power x. By taking LCM, e to the power x whole square minus e to the power x into 2y, and I'm cross multiplying and bringing all to one side, shuffling all to one side. So e power x whole square minus e power x into 2y minus 1. So it is quadratic in terms of e power x. So quadratic equation in e to the power x here, e to the power x. So solving for e power x. So e power x is equal to minus b 2y plus or minus. So b squared means 4y squared minus 4ac. That means plus 4 whole divided by 2a, 2 into 1, 2 into 1. So here I have plus minus, but e power x means always positive only. E power x is always positive, it won't be negative. So discarding negative sign. So e power x is nothing but y plus under root y squared plus 1, y squared plus 1. So e power x is e power x is e power. So therefore I need to find out x here. So what is x here? Logarithmic. Logarithmic y plus root over y squared plus 1 to the base e. So if I remove e, it converts vice versa, logarithmic to exponential, exponential to logarithmic. So therefore x is equal. So what is x now? Sine h inverse y. So sine h inverse y. So here variable is not the matter. You can take any variable here. So therefore sine inverse x will be equals to logarithmic x plus under root x squared plus 1 to the base a, to the base a. So this is the sine h inverse x. So if you know one function, you're able to transform one function into inverse hyperbolic function, you can switch to other also. Like by using this one, you can solve cosine hyperbolic as well as tan hyperbolic, cot hyperbolic. So once if you are able to do one thing, similarly you can extend to the same to the other functions also. So therefore sine h inverse x will be, sine h inverse x is nothing but logarithmic x plus under root x squared plus 1 to the base e. So what is the advantage of this one here? So d by dx of sine h inverse x. You know the derivative of this function. I got differentiation also. Differentiation also. Suppose integration of sine h inverse x. Integration of some function is given. Integration of this writing most of the time 1 by 1 plus x squared. 1 by 1 plus x squared you are writing. 1 by root over 1 plus x squared you are writing. Logarithmic. Vice versa relation you can form. So calculus to normal hyperbolic function. Normal hyperbolic functions. So what are questions here? Suppose sine h inverse. Sine h inverse 2 they asked. Directly I can find out. Logarithmic 2 plus root over 5. Suppose you're asked to find out sine h inverse 3. Sine h inverse 3 means logarithmic 3 plus root over 10. So like this you can replace x by any value also. So I am able to switch over one function to other function, vice versa inverse function here. So sine h inverse x will be nothing. Here also you can find domain here. Domain, I can put any x value here. I can give whatever x may be 0. 0 means log 1 I am getting. X may be minus 2, it is dominating. X may be minus 3. Minus 3 and 3, it is dominating here. So I can give any input to the function here. So domain is set of real numbers. Range also I am getting. So range also equal to set of real numbers. So if I know function easily, what are the possible inputs that will come under domain? What are the possible output that will come under range of the function? Thank you. Thank you so much.